This video introduces our system, which explores the sensitivity of choropleths under attribute uncertainty. We use Moran's I as the indicator of spatial autocorrelation. Positive Moran's I means that nearby units have similar attribute values, while negative means dissimilar. Correspondingly, we use local Moran's I to indicate the local spatial autocorrelation per geo unit. When a unit is similar to its nearby units, it will have a higher local Moran's I. The system has an attribute uncertainty specification view to enable examining and specifying the uncertain range. It also has a region-based impact profile view, the t-SNE view, a scatterplots view, and a dual-choropleth view to visualize the impacts on each region. The user can specify the uncertainty range by loading a file or manually setting the value. The impact profile view will switch to the impact river for single attribute analysis. The impact river sorts all spatial units according to a weighted sum of the impact. We load the Chicago crime data and visualize the theft events. We classify the spatial units into 6 classes. We set the change from negative 10% to positive 10%. Step equals to 1%. The impact river displays a summary of all simulations results. We see that when the value changes between negative 2% and plus 2%, most regions have no impact. Some regions only show impact when the value increases, while some only show impact when the value decreases. We find some influential regions. For example, when the theft value of region 36 decreases by 3%, it changes group, and a new group is created. When the value of region 57 decreases by 3%, this region will move to the lighter color class. The local Moran's I of the regions to its east and west decreased, but the indicator increased for the region to its north. We find another unit, region 9. When its theft value increases by 3%, it is reclassified into a darker color and detached from its neighbors. We use the U.S. Census dataset to investigate the education level of the southwestern United States. We select the secondary education rate and the higher education rate and group the regions into 5 classes. The parallel coordinates show that some regions have a high level of secondary education but a low level of higher education. We specify the uncertainty range of both attributes as negative 3% to plus 3% and set step equals to 1%. In each matrix, the columns represent the uncertainty of the secondary education rate, and the rows represent the uncertainty of the higher education rate. Overall, only a few regions in the central and west area are sensitive to the uncertainty, but northeast regions have high sensitivity. We turn to the similarity-based layout. Most changes are visualized on the lower right corner of each matrix, so increasing the value will have more impact than decreasing the value. The purple regions are sensitive to the secondary education rate, and the gray regions are sensitive to the higher education rate. When the County Douglas increases its higher education rate by 1%, it will flip to the group with a higher education level, and the classification results will change greatly. There is another sensitive county in Utah. When the secondary education rate increases, it moves to a group with higher education level, and similar regions are also reclassified. The Northeast, Northwest, and Southwest regions have the local Moran's I decreased. The eastern area and the center area have the local Moran's I increased. We select 6 attributes and classify the regions into 6 groups. The green and yellow groups have a high percentage of foreign-born persons and high education level. The gray and purple groups have a low education level and a low median household income. We set the uncertainty range from -5% to +5% with a step of 2%. We filter the regions by their impact. Looking at the profiles of the regions, almost all of the matrices change their colors along the columns. This indicates that the uncertainty of foreign-born persons has a broad impact on the classification results. We find a county, San Benito. Its bottom left triangle is colored. This means when the value of foreign-born persons and education changes, San Benito will impact the classification result. We expand the matrix. The submatrix changes its color along with the third attribute. We find that the uncertainty impacts the green and yellow regions. The local Moran's I has increased in the north area but decreased in the west area. To explore impacts of different attributes, we drag the median household income to the second place. We see many triangle patterns in these matrices. We look at the county carbon. It will impact the classification results when the median household income increases. We expand the matrix. It impacts more when the value of foreign-born and poverty change. We also find that carbon is easily changed into the cyan cluster, and it will impact many other regions to flip their colors to cyan. The local Moran's I of the west areas decreases, but north areas increases. Finally, we move the poverty attribute to the second position. We find the majority of the matrices do not change along the row. This indicates that the classification results are not sensitive to the uncertainty of the poverty attribute. This work helps analysts and map designers to understand how data uncertainty could influence their visualization and statistical analysis.